Okay. Good evening. I presume everyone has successfully completed the homework? Okay. Any issues on the homework from this week? It was really a rather easy week, very few videos to watch. I put 3 links to various pages of the VCarve documentation. These are the links to the 3 toolpaths that we're going to study tonight. Everyone's had a chance to just glance at that documentation? Okay.
They have videos on them too.
Yes, understood.
Which are helpful.
You know, I had my career just reading books and interpreting technical information from books. And it's so nice to have a video that we can sit back in a easy chair and just hope that it doesn't put me to sleep. That's more and more. And you can learn so much from the videos. That's true. We're truly living in a world where if there is something we want to learn, no matter what it is, calculus, medicine, we can go to YouTube and there's going to be a video that will talk to us on that subject. And if we pursue it, we can go as deep as we want to in that topic. Whether we can trust the information is another question. They do have some dubious, the minds might not always be perfectly synced with the topic when they do the upload. Okay, has there been any problem in the videos that you've watched so far for the class? Now, I did hear last week there was one video that it did not work for somebody. Sam?
I had trouble with lesson 4 homework where I couldn't get the download. I couldn't get it to open up.
Okay, so that'd be an issue on joesboat.org.
Yeah, it was.
And it was after I did the updates last night?
I haven't checked it today.
Okay. I'll look at it also, but if it doesn't work, please send me a note so I can fix it. And that's really true for any of the homework assignments. If there's an issue, send me a note and let me know about it.
This is an odd issue. I downloaded the PDF.
Okay.
Printed. I'd like to print the class. And the odd pages were offset about 1.5 inches.
Don't you love Adobe products? That could be from the source. Send me a note on it, and I'll check the source for that.
It worked fine on the power.
Yeah, right. I do not develop using Adobe tools. All of the PDFs I create are derived from some other program, and it just could be a part of that transfer that shift occurred.
If anybody else experienced it, there's a good chance it could have been something like
that. Okay, so I guess 2 other questions. Has everybody got their CNC blank ready? I look around the room, I see 5. Okay, Roger, you're...
I got the wood there, but I haven't cut it.
Okay, all right. And you've been traveling?
Yeah, I just got back.
Okay. At this point, with the material that we have covered and the material that we'll cover in the first 15-20 minutes tonight, we will have covered all of the details that you would need to walk in the room and sit down with me and cut a project, a vanilla project that you've downloaded from the website. You've studied all the details of, and that's the one I wanted to mention. You've studied the 58-minute video that gives you all of the details for using the ready-to-control software. Okay, good. So you're in a position to walk out and turn the machine on and begin to set it up.
Absolutely.
We'll double check that in our first sessions. Okay. Oh, let's see. Now, it turned out that last week I did not complete all of the topics that I wanted to talk about. I think I'm about 20 minutes behind right now. And so tonight I'd like to pick up and spend 20 minutes to complete all of the session 3 material. Okay. We're going to, in this 20 minutes, we're going to touch on each of the 3 toolpaths that you will need to use to cut your project. And we're going to talk about them relative to where they fit. If I think about the back of the blank, and I'm calling this side to be the back of the blank, okay? The first toolpath that would be executed when we begin to cut are the alignment holes. You can see one here and one on each side. And the alignment holes, while it looks to me like just a hole drilled, it does not use the drilling toolpath. There is a drilling toolpath. Here we use the pocket toolpath because I did not want that hole to be a pure 0.25 inch. I wanted it to be 0.26 to give just a little extra room where we could easily slip a dowel in to align everything. So this is cut using a pocket toolpath. And on the back of the box, on the back of the blank, there are 2 other cuts that use the pocket toolpath. There's a cut for a rabbit here along the bottom of the top of the box, and there's a rabbit here along the bottom of the back of the box. So all of these use the pocket toolpath. So let's take a look at the pocket toolpath and just look at the parameters that we have to consider if we are setting up to do a pocket cut. So here I am. I'm in the 1/2 inch material medium box, and I'm going to switch over from the design tools on the left to the toolpath tools on the right. Now, last week I identified the profile, the pocket, and the V-carve icons, and each of these icons will load a program that is fine-tuned to handle that particular toolpath. It will display a dialog where we can specify the parameters. So tonight I'm going to start with the pocket toolpath. I'm going to look at the blanks. I'm going to back out and I'm going to load the alignment toolpath. And the first thing you'll notice when I open that program, that each of the circles are highlighted in the magenta color, meaning that we've identified the vectors to the tool path that we want it to cut. So, and if I look at the details of the pocket tool path, beginning at the top, the first is the start depth, and you'll notice it's set to 0. Now that is, in this case, the surface of the material, the 0 point, the surface of the material, and the cut depth is going to be, for the alignment holes, 0.75. Now, of course, we know that this material is a 1/2 inch, so we'll be cutting 0.25 inches into the spoil board to create the holes that we can use to align the other side. Going down, the next entry is the tools. Now notice that this is not a single entry. This is really a list, and I can add additional tools to this list if I chose to. And let's think about this just for a little bit. I have, potentially later on, I'm going to be cutting a rectangular pocket. Now, and if I were to be using, and in my wildest dreams, I'll say a 1/2 inch end mill, I will be able to clear most of the area of a pocket, but I will not be able to get tight in the corners. Okay, so the software provides the ability to set up multiple tools that can be used in sequence to first cut most of the material that the tool will handle, then switch to a smaller tool to begin to clean up nooks and crannies that the first tool was not able to cut. Any questions there? Now in this instance, of course, I'm cutting a 0.26 inch diameter hole, and I don't need any clearance activity, but I wanted to make sure you understood that capability was there, built into the toolpath software. Okay. If I go down from the tools that I'm using, it's telling me what tool I have selected. It's an end mill, part number RU2100, and it's 0.25 in diameter. But what about that tool itself? The tool itself comes to me with a set of parameters directly associated with the tool, and not directly with the tool path. So let's drill down and look at the tool, the 0.25 end mill. I'm using the edit button to do that. If I start at the top of the information about this tool, it's identifying it's an end mill of a particular size. There's some notes, and they're interesting. It's telling the software that this is an end mill, and there are specific properties of an end mill: flat bottom, either a straight cut or a spiral cut, and whether it's an upcut or a down cut. Again, the unit is being measured in inches, and the diameter is 0.25 inches, and it does have 2 flutes. Here is a setting that I have chosen to be easy on our machine. For a given pass of the tool, for whatever work it's doing, whatever depth it's cutting to, it's going to use multiple increments, and it's going to cut 0.125 inches on each pass it makes to cut the information, to cut the wood. Now, why is it 0.125 inches? And I think I've already given a hint. I make easy on the machine. The general recommendations in the community is that the depth of cut can be up to the diameter of the bit. Okay? Can be up to the diameter of the bit. They do not recommend you go the full depth. The force it places on the tool would be a challenge, would generate a little more heat, and would possibly break the tool. And by the way, I have broken a 1/4 inch end mill on our machine. I have. You know, we're going to talk about tools later on tonight. Take a break here just for a moment. I mentioned last week that some of us have decided to purchase our own tools and not depend upon the unknown status of the workshop tools. And over the last week, Bob and I worked together to identify a set of tools, a starter set. It's from Whiteside Engineering. They're actually it's called Whiteside CNC. They're located in North Carolina. It's an American manufacturer. And it's a rather high quality tool at a mid-range price. And many people within the industry utilize Whiteside. This is a starter set, and it turns out, I think, Bob, you went aggressive with Amazon.
Yeah.
You bought two?
Yeah, I figured it.
I'll pass.
With two, but I have someone that's generously decided to take one off my hands.
Now, as I pass it around, I'll just emphasize that that is a 1/4 inch end mill here that's still in its protective coating.
They're all covered.
Yeah. Okay.
What did said,
Pardon?
what did said box of bits cost?
I'll give you the exact amount.
It's in the neighborhood of
It's
$80.
$174.20
For both?
for the whole set, $174.20
Okay.
for one set.
You were just saying $80 and you said $175, so.
For one set?
$174.20 for one set.
Really? Okay, got it. I'm not arguing, I'm listening.
Let me make sure I'm talking, maybe that's for, hold on.
Is that after the tariff? I did hear it say it was made in the United States, but I wasn't sure.
You know what that? No, it says quantity one.
Right there, this is from
What?
Amazon.
Okay.
So is that more than you would expect to pay for starter sets?
No, if I break the tools apart, I can come close to that number.
Okay.
They're anywhere from
I-
$25 to $35 a bit if you buy them
Yeah.
individually.
Yeah, the end mills are on the low end of the cost. They are $20, $21, $22 in that range. When you get up to a V-bit, they're in the $30, $35, $40. And then when you get to the tapered end mills, they're a little more expensive than that. So there's 5 bits in this package, and so it can get there. I just don't remember paying that much for mine, but that was 5 years ago.
Price of poker's gone up.
Okay, so we'll talk more about bits later on, but I wanted to get the end mill in the conversation. Let's see. We are talking about both the pass depth, and the next point is the step over. Now, for other tool paths, you're not going to see step over, but for For an end mill, especially in a pocket toolpath, there's a decision the software has to make as it completes one pass and starts the next pass as to how it's going to cut over the path that it's already cut, the step over. So here we have it set to 0.2, which is an 80%. So we're going to make multiple passes and fine-tune the cut at the bottom of the pocket. And of course, you can increase this value, which will decrease the step over. And we quite often do that if we're doing a simple clearance. You can easily step over on a clearance and then later on clean that up. As I go down, the feeds and speeds is next, and lots of conversation on feeds and speeds later on this evening. I'll just say right now that we've chosen to run it at 160 inches per minute, and if it's doing a plunge, it's going to run half of that speed at 80 inches per minute. There's a conversation pending about chip load, and I'm going to reserve time until then.
One of the videos, I was doing the inlay, I watched all the inlay videos as well. He bumped it up from 60 inches per minute to 80. And I wondered about the chipping on that because when he finished, he had to clean it up quite a bit.
Okay. Some information about our machine. The Next Wave specs our machine at a maximum of 200 inches per minute.
Wow.
Okay, 200. I don't push it that hard. And you can see I've set it to 160 in this instance. Okay. So that is the data about the tool for this tool path. Now keep in mind that these settings are hierarchical in that this same tool being used in a different tool path may have a different set of parameters. Okay? And that's under the control of the man creating the tool paths to choose the speed for a particular tool path. Cancel out of this. Going down the settings that are available for the pocket tool path, the direction of cut, and we've got a choice of offset and raster. Right now I've got it set to offset, which is going to be a circular pattern until everything is cleaned up. Let's switch to raster, and you'll see by the design the change in the motion that the bit's going to make. It's going to, instead of a circular pattern, it's going to be a back and forth pattern. And with that back and forth pattern, you have the ability to determine whether it's left to right, up or down, or whatever degree in between you want that zigzag pattern to occur, leaving it back on offset for right this moment. Plunge moves. I mentioned last week when we were talking about end mills that because of the design of the cutting faces on an end mill, that it's not a natural drill. So for some pocket cuts, instead of going directly into the wood in the Z direction, you can go in at an angle sloping down, and that's easier on the bit. Notice here there's a setting. If I were going to have a ramp on this tool path, I could set a distance, and I typically select 1 inch. So that means I would go down for 1 inch, and then the software is smart enough to know that he's got to go back and clean up to make everything The other parameter I wanted to mention was the pocket allowance. Now, keep in mind that if I'm cutting out, say, a bowl, and I'm going to have nice sides on that bowl, as I cut down in 1/8 of an inch increments, okay, the tool is naturally going to leave a little bit of fray out along the edge of the wall. Now, it doesn't make any difference on the various paths he's going to take to clear out all of the material, but on the final edges of that bowl, you want it to be pristine, very, very smooth. So there is a provision here that you can set up an allowance, a fraction of the cut that you want to save until the last minute. And instead of ramping down an 1/8 or 1/4 of an inch at a time, it will make one pass the full depth of the total cut with that fraction of the wood being shaved off in one slice. That is the pocket allowance. And the last one I'll speak of tonight is the selection order. You can specify a selection order by the sequence that you identify the vectors to be cut with this pocket. There is a home position on a vector we'll talk to later this evening. Okay, with that, that's a quick overview of the end mill tool and also an overview of the pocket tool path that would be used to cut the alignment holes. It's telling me, or it told me, that it was going to cut into the spoil board, and I said yes, thank you, because really that's what we want it to do. Okay, closing out of that particular tool path, let me quickly go into the what I call the rabbit tool path, and that rabbit tool path is going to cut the pockets where the bottom will slide into the front and the back. You can see the magenta here and the magenta here. And then on to the text. The text, and I'm using first text as the example. This is what may be printed on the back of the box top. And this is simple text, and we choose to cut it using the V-carve tool path. Now, the V-carve tool path would apply to this text, and on the other side of the board, the patterns that would be on the front of the box and the top of the box. And also, if I were to turn it on for pattern 1, we would also cut the design for the box ends using a V-carve tool path. Let's take a look at the tool path. Again, starting from the top, the start depth happens to be 0. Now, it turns out that for V-carve purposes, we might want in the future to cut letters or a design at the bottom of a pocket. Okay, so here I have the ability to tell the software the starting point on the material that this V-carve tool path is going to cut into. Now, for this example, of course, we are cutting from the surface of the material. Okay, as I go down, there is also a flat depth setting, and right now I have it is not set at this point. It is feasible. Did everyone watch the video where the lady from Everwood Creations talked about the V-carve toolpath and how the software is going to choose how to cut into between the lines? Okay. That was a homework assignment last week, okay? Going around everybody else's. So based on the spacing of the lines, it is feasible for the V-carve toolpath to cut below and into the spoil board. So there is a setting here to establish a limit as to how deep I will go. It's not set here, of course. With this text, it's pretty safe just to cut the pattern. Again, I could use clearance tools. Should I be cutting a wide area or a wide letter, I could use a clearance tool to clean off the bottom and then run around the edge with a V-bit. Okay? And the software is smart enough to understand that if you supply a clearance tool, that he will run the clearance first, and then later on he will run the V-carve. If I go further down below, again, and it's not needed for a simple V-carve, but if I were using a clearance path, a clearance being roughly equivalent to a pocket, it gives us the option of an offset pattern or a raster pattern. Again, we are able to choose the starting points, and with that is the V-carve toolpath. It's pretty nice here. They've shown us in blue here the path of the bit, and they're showing us in red the path of the machine that is going to be used to put the bit in place to begin to plunge and to cut the pattern. You know, V-carve makes it rather safe to put a tool path together and then to evaluate what I have in place. I can look at how the cuts are going to perform and the final product using a preview toolpath tool. Here's a preview of the selected toolpath. Now that was just the V-carve of that text. But if I choose to, I can reset everything and I can run all of the tool paths for the back of the material. So here we are cutting the design of the ends. We're cutting the pocket. This will be the rabbets on the bottom of the front and back. And you can see here we're cutting the alignment holes. Okay. Now we've covered two of the tool paths. We've covered it for the alignment holes. And yes, we could stop and we could look at the settings for the rabbits along the bottom and the back. But the same set of parameters, we might have different values for other tool paths. And between now and when you cut your box, for those two tool paths, I would recommend that you review the settings and just, does that seem right? Is there a mistake there? Yeah, for sure, there could be a mistake in the file you received. So go through the values, see if it makes sense, and there's something we can talk about for your cut when we use the machine to cut your material. Okay, let's flip back over to the other side. There is a tool here to flip to the other side. You've all seen this in the videos and you've practiced it. A question I didn't ask earlier. Who here has a file that's close to being cut? Bob has one. Anyone else? Any? Okay. All right. Okay, I'm on the front of the box. Let's go to the two-dimensional view. The last tool path I wanted to talk to in detail is the profile. And it turns out for this box design, we are going to use two profile cuts when we have the material positioned with the top up. I have a profile that's going to cut the box top and the two sides. And I have a second profile that's going to cut the box front and the box back. Now the reason, has anyone figured out the reason for the two profile cuts? The reason is that on the, we talked about earlier, we have a pocket cut here and here on the front and the back. Okay, so if I were to cut the front and the back with the same profile cut I used to cut the top and the sides, I would cut through any tabs that were on the front and the back. Let's take a look. We'll start with the with the top and ends, and I'm going to quickly calculate, and I'm going to display that tool path, and you can see that on the top and the two ends I have a tab that's going to keep this component in place. Okay, but those tabs are going to exist from 50% into the cut to the bottom. Okay, where if I were to use that same tab to cut the front and the back, the pocket cuts that I used on the back would prevent us, would have cut through the material that would have been the tab. So what we are doing on, and let me close out of here and go back to the profile cut for the front and the back. You'll see when we look at the tabs, the actual thickness of the tab is 1/2 inch. The tab is going to occur all the way up to the top of the material, and it's going to exist from the top of the material to the center of the material. because the bottom of the material there has been cut away with the pockets. Pretty straightforward? Okay. In my 20-minute discussion, I've taken 30 minutes. We are clearly running behind. But at this point, we need to finish out the profile toolpath. And here I am, I'm focused at the toolpath for the front and the back. So starting at the top, I have the start depth, which again is going to be 0. Okay. If I did have an area where I had already cut a pocket and I wanted to cut a profile out of that pocket, I could have a start depth at the top of the pocket, the top of the bottom of the pocket. For the cut depth, I'm going to cut down a 1/2 inch. Now for the first time, how do I know that I want to cut a 1/2 inch? Built into the software, I have a standard set of parameters, X, Y, Z, okay, where the software itself from an earlier setup screen knows the value of X, Y, and Z. So, and to tell it I want to cut through the full depth of the material, all I have to say is let's cut Z depth. So I'm just entering Z here. Well, I'm going to enter Z here. And I'm going to press the equal key, and that's going to, the 0.5 is going to pop up. Now keep in mind, I'm doing essentially arithmetic in a dialog box. Okay. I can do simple add, subtract, multiply, divides, okay, as long as I write out the formula using basic algebra equation and then hitting the equal key, and whatever the product of that equation is will be entered into that dialog box. Okay. I also need to mention that and this is probably mentioned in the videos, that all of the dimensions for Vectric are in decimal format. You can do fractions, of course, 1/16, as long as you push the enter key, or excuse me, the equal key, to convert that to a decimal. Okay. Going down for a profile, selecting the tool, the same as before, the 1/4 inch end mill. Here it's telling me the number of passes that it's going to take to cut the material. Now for some cuts, that might not be adequate. You might need to go even finer or grosser than that. So for the profile tool path, they do allow us to edit the passes, and they show us a dialog box here where I could turn 4 paths into 2 or into 7 and specify the depth of each of those passes. That's something you might want to experiment with as you're playing with the software. Going down further, because a profile toolpath, and oh, by the way, a profile is a very simple toolpath. It will do whatever you tell it to do. If you want it to cut on one side of the line, it will. If you want to cut on exactly on the line, it will. And you do not need to have a closed vector for a profile tool path. It will simply go to the beginning of the vector and cut to the end of the vector, repetitive times if necessary, and do. Okay. But he's never going to venture outside of that path. He's going to stay on the edge of the vector or the center of the vector. As I go down, again, I can do a separate last pass. And this is a similar capability as I mentioned in the pocket cut. Here we would reserve a tiny bit of the material, say along the edge of the vector. I would go multiple passes till I cut the full depth of the profile cut. And then I'm going to take a last step of going back and shaving that excess off along the side of the vector. Well, I presume it's going to be a very thin cut along the side of the vector. And again, the same goal. On the edge of a piece of work, you don't want any little frays caused by the bit not completely cutting the wood. I've spoken to the tabs for the two profile cuts. I will show you real quick your ability to go into the 2D view and specify where you want the tabs to occur. The little the little yellow background T is going to be the location of each tab. And again, I can add ramps to a toolpath, but with the profile cut, they give you three options as to how the ramp is going to occur. My favorite is selected here. It is the spiral ramp. And with the spiral ramp, when I'm cutting a closed vector, I'm going to start above the material. And as I move along the cut, I'm going to gradually lower the bit until I reach the cut depth of the first pass. And there I am at in this instance, an 1/8 of an inch cut. And I'm going to continue that downward spiral for that 1/8 of an inch cut until I reach the bottom of the cut. And then I'm going to of course he's going to recognize he's at the bottom of the cut. And now I'm going to cut flat around the remainder of the cut to fully cut the profile. Did I mess that up? Anyway, it's a spiral. You can see the spiral if you slow down the, I'm going to calculate, and I'm going to automatically be put in the preview toolpath tool, and I'm going to slow down the cut, okay, moving that bar over to the left. And I'm going to now preview the selected toolpath. You can see it going around. And if I were to come and tilt the program, to tilt the screen, I would be able to see the 1/8 of an inch cut that it's constantly doing around the circumference. Okay. And you've seen the previews in the videos that you've watched. You've seen the previews. You know that we can do a full preview of all sides. He's doing it pretty slow right now, and I'm going to speed it up here in a moment. Here he's cutting the design on the back of the box. Here's a design on the front, and here's where I do need to speed it up. Of course, this is a little bit faster than the machine itself can do it. Oops, I forgot to not select that one. Sorry about that. Okay. More demo than I had anticipated. Okay, this is where I had expected to end last week. And at this point, we've done the homework from session 3, and now I've covered all the material from session 3. Everyone can name the 3 tool paths, and everyone can look at the file you've downloaded to see the details of the pre-established tool path for your cut. Okay, pretty straightforward. Have you experimented with that in your?
Not to this extent, yeah.
Okay.
Matter of fact, what I've done, I'm not sure that I've done it correctly now.
Okay. Well, that's what we are going repetitively, looping around until we are comfortable handling the material. Let's see, I've gone for 50 minutes. Let's take a 3 or a 5 minute break right this moment. Let me rest the voice for a moment and have a sip of water. Let's resume at 5 minutes to 5. 5 minutes to 5. We begin session 4. We need to spend a few minutes talking about tools, the tool database. I spent 5 or 7 minutes talking about Z options, Z depth, Z measurement, Z calibration options. I'm going to glance over that tonight. We'll can touch more on it in the future. I've talked a lot about the toolpath details. I've talked a lot about pockets, clearance pockets already tonight. So again, we're not going to spend a lot of time there. I want to touch a little bit about the post-processor and how that has to be set into the machine so that your toolpath is converted to the correct G-code format for use in the machine. And then we're going to switch over to focus on customizing your box. Box size is pretty much fixed. I don't anticipate many people will branch beyond the 14 1/4 by 17 3/4 inch blank. You're essentially pushed into multiple blanks at that point. And I do have a posted husband and wife 3-dimensional that is sized so it does require 2 blanks to do all of the cuts. And then we're going to spend a lot of time on box decorations, talking about the inspiration, the tools, and the various patterns that you can easily do just with a V-bit. Okay. Talking about the tools, we are often dealing with absolutes. No choice whatsoever. Once you select the material, you're either dealing with hardwood, softwood, or soft metals. Okay, that's an absolute. So everything is going to have to be tuned to deal with that wood. You're not going to be able to run the bit through the wood to cut as fast when you're dealing with hardwood as you could have if you were dealing with softwood. Pure and simple. Same thing with metal. When you're cutting with aluminum, you're not going to be able to run it as fast if you're cutting into hardwood. Another absolute is the tool that's needed for the path. It's either going to be an end mill or it's going to be a V-carve. And the definitions for those tools are often provided by the manufacturer, and we'll cover that later this evening. The manufacturer is often going to specify the maximum speed of a tool, and sometimes the manufacturer is going to make recommendations on the chip sizes that you can cut with your tool, with that tool. Or I should turn that around and say that the chip size that's going to optimally remove heat from that tool. Variables we deal with, of course, determined by the material type, the toolpath needs, and the machine capability. Cut dimensions, of course, the depth of the cut I've talked about tonight, the step over I've talked about tonight, but those are variables that's under your control. Also, I've talked a little bit about feeds and speeds, and here we're talking about the longevity of your cutting tool. The RPM that the tool is going to turn, the feed rate it's going to push into the material, and the plunge rate that it's going to push into the material. The tool library is a hierarchical database. It has an entry for each physical tool in your inventory, organized by tool types, organized by end mills, engraving bits, tapered ball nose bits. It is a tool library is often available from the manufacturer of the tool. And since I mentioned Whiteside tonight, Whiteside does provide a tool database that you can simply download from their website and load into your tool database. And instantly you'll have a lot of information about each individual tool that Whiteside provides. Like I say, the database itself is maintained by the user, and you can add your own parameters to the tool database that tool will carry from toolpath to toolpath to toolpath. And then, as I mentioned earlier tonight, for a given toolpath, you have the ability to customize the tool parameters for that tool path, and that customization will only apply to that tool path. Now that is the structure of the database. And I'll do some examples here in just a moment. I want to emphasize that Vectric recognizes that there are some very creative individuals out there that might design their own tools. Machinists maybe would do that, maybe a particular pattern. So they do provide a method that you can, that has all of the tools, the graphics, to define the parameters of a tool to the software, and you can name it and use it in your database. I'm not going to cover those details tonight, but in one of the video series that's in the optional homework, there are videos describing how to enter information about your own tools, or a particular shape of your tools. Let's jump over to the software. I'm going into the tool database. Lo and behold, there's an icon here for the tool database, and I just don't see it. Editing the tool path, there it is. My goodness, three bits. I should have found it instantly. Yeah, here's the dialog for the tool database. There's some global settings like hardwood, acrylic, MDF, softwood that you have that you can specify. Ever since I've been using the product, I've always kept it at hardwood. Notice I have categories of bits: laser tools, metrics tools, Whiteside router bits, imperial tools, and this imperial tools is one of the database content that comes with the Vectric product. So you probably already have an Imperial Tools database in your installation. We're going to focus on Joe's bits tonight because they're the ones I put there. End mills, look at the number of end mills we've got. Here's one that's named Whiteside. I've got 1/8 of an inch. There's a 1/16 of an inch somewhere. And these are all the standard Whiteside definition that I've taken and modified for what I want that bit set to when I load it. So that ability is available to you. I would recommend that you start with the standard Whiteside list of bits, and then you add to it or change it as you step forward. Ball nose bits, V-carve bits. Here we have the standard 90, the standard 60, and here is a 30-degree bit, but it's named slightly different. It's named a 15-degree bit because that manufacturer looks at things a little bit different. They, instead of measuring that, they measure half of that. So that is the database. That is how you modify it. No, that is how it can exist. But there are tools at the bottom that you can use to load additional information. An example is the Whiteside. There's a symbol here that lets you into the directory structure, and when you download the file of the Whiteside bits, it will be a file named .tool. So this particular file operation is going to look for any file with a .tool suffix, and it can either be an individual tool or it can be the complete set of the Whiteside tools. And for tonight's homework, I provide data on where the Whiteside website is, how to download their tool library in the Vectric format. Okay, so the tool database we have, and you can move tools using these icons below. You can move tools from database to database. Okay. We spoke last week about tools becoming dull, heat and abrasive material. I used the phrase then, make chips not dust, and one of the homework assignments for this week was a very short, I think it was about 10 minutes, of a young man named Kevin out in the Midwest talking about his view of speeds and feeds and providing some settings, some recommendations from his business. Essentially, the faster you move the cutting head, the smaller the chip size is going to be. I'm moving it fast, so the RPMs of the cutting head can only cut a little tiny bit. Okay, and for a given speed, if I want larger chips, I simply slow down the bit. Does that make sense? I mean, yeah, and I mentioned earlier that the maximum speed, the maximum cutting rate of our system is 200 inches per minute. There are machines out there that can cut 400 and 600 inches per minute. Okay, And many of the recommendations you're going to see from tool manufacturers are focused on these unlimited machines in the commercial world. We are not there with those unlimited machines. So I'm going to point out, as I switch over to the internet, and point out, here's the website, and in the library, in the CNC file library of the website, I've loaded it in the root of this set of folders several, one from Amount of Tubes, one from Freud, one just named Feeds and Speeds. I think this one, Feeds Space and Space Feeds. I believe that is from Kevin with his recommendations. So as you plan a tool path, it is worthwhile going to these source recommendations from manufacturers and or professionals in the CNC world and get their view of a particular tool and the chip size that that tool should generate for optimum performance. That's really the, so I would recommend you take a look at these books, read through some of the formulas for chip size, and then when you get back into the Vectric software and go into the tool database, and I'm going to choose a profile to I'm going to choose one of the profiles and go into the edit the tool itself. And when I focus here on the speeds and feeds, notice that if I were to have the spindle set at 20,000 RPM and I drive it at 160 inches per second, for a maximum rate cut, I'm going to be generating 4 thousandths of an inch chips. 4 thousandths of an inch chips. Now if I, let's slow down the feed rate to 16,000. And all of a sudden I've got 5 thousandths. Chips are expected to be 5 thousandths of an inch. Now keep in mind you can manipulate the speeds and the rate of cut to get the optimum size, chip size, for that particular tool path. We're into the art of things now and not the science. We're into, let's tune it. Going back to the PowerPoint, I mentioned that it has controls to provide new tools, chip size. Last week we talked about Z calibration. Calibration to material surface versus calibration to tool bed. There's no right answer. You can do it either way. This is a list of results should you not have the precise thickness of material you've told the software about, and what's going to happen with the cuts in that case. Pretty straightforward. If I calibrate to the machine bed, I'm very seldom, if ever, going to cut into the machine bed accidentally. Okay? And if I always calibrate to the material surface, and that material is not precisely what you've told the software it is, you're going to run the bit along the spoil board surface. Straightforward. I often use, for personal projects, I often use the machine bed. And for many of the projects I create for the classes, they're going to be calibrated to material surface. And that's because we want the V-carves to really pop out. And that's when you're working with material surface. You're really biasing it towards the V-carves. I'm going to close by talking a little bit about the various configurations. When I go into V-carve and I go into the let's generate a toolpath. Let's generate the file, the tap file. Here it's specified that we are generating for a Shark HD510. That's our machine, and that we are using a normal toolpath, a normal next wave toolpath. Should it be a rotary job, I would have a rotary toolpath. And should I be dealing with metric, should I be in Europe, I would probably be working in metric, and I could choose a metric toolpath, a metric biased. Now what I'm doing here, when Vectric creates a toolpath, he could care less about the machine. They're going to do everything necessary to build a database of information about the toolpath. Okay. The final step before he converts that toolpath into the G-code is to consider translation software. It's called a post-processor. That post-processor understands the capabilities of the machine. Some machines have a controller that can easily cut a circle or a slope at a particular dimension or angle. Okay, some can't. Some have to convert that circle into a step of little tiny cuts to walk you around that circle. And those are all decisions that's done in the post-processor after all of the details of the toolpath have been specified. Let me double check. Of the videos that we have watched, how many of them have spoken to the node editing mode features? I see a lot of blank faces.
I can only remember one. And
At least one, yeah.
Yeah, but I can say I couldn't give you a definition of node right now. I remember watching it.
Okay,
I remember
then.
the word, but I don't remember the.
Well, this is important.
Yeah.
So let's spend some time here. I'm going to go into vCarve to do this explanation. And I'm going out of my toolpath back into the design side of the software. Early on, I introduced in the Edit Objects area 3 selection tools, or I should turn that around, 3 modes of selecting a vector we want to work with. Okay. The one all the way to the left is normal mode. When I select a vector in normal mode, it appears as a magenta dotted line. And if that is a solid line, that means that that vector is part of a group of vectors that is selected by one action. Okay, one action. There is a mode that gives me additional controls where I can change the dimensions of this vector. If I grab it in the side, I can narrow it, and then if I Control Z, I'll restore the original dimensions. If I choose it in the corner here, I can reduce both the width and the height of that vector. And again, I'm going to Control Z back to its original form. And if I choose up in the top corner, I can rotate that vector. But all of the changes that I've made, I'm still dealing with a rectangle. I've changed the size, but it's still a rectangle. It's still a closed vector. Okay, could be used as a pocket cut, and let me again restore it to its normal position. Now both of those are normal vector operations. Okay, I'm dealing with a rectangle, I'm dealing with a circle or a star. I can manipulate the size. I can even change the number of points on the star, but I'm still dealing with a simple vector. The center selection is node editing mode, and when I can enter node editing mode two methods. One, I can click on this icon, or I could simply press the N key. Here I'm touching the N key. And everything changes. It's still selected, but it's no longer a simple dotted magenta line. I show 4 points. One of them happens to be green and the other 3 happen to be black. And those points define the tips of the vectors. And bear with me, it's not in my mind right now, but there is a name. I'm still in node editing mode. I lost my selection, but until I press N again, I stay in node editing mode. In node editing mode, I can grab a corner. Okay, it's no longer a rectangle. Okay, in node editing mode, any corner of a rectangle or a square is a control point. And because I'm in node editing mode, if I don't have the number of control points that I need, I can simply add a control point. Let me select it again first. Go back into node editing mode, select it, and I can insert a point here. Well, and I did insert a point. So now instead of a trapezoid, well, now I've got a rather complex, I guess, is this a trapezoid? Yeah, anyway, it's interesting, whatever it is.
Goes around this and went to a pentagon.
So yeah, I can manipulate the shape of a vector. Let's see what else I can do. I'm right-clicking on the line to give me a list of items where I can select to change. Let's cut it. Okay, where'd I cut it? Where'd I cut it? There I cut. That's where I cut it. So I no longer have a closed vector. Okay, I can manipulate it. And of course, I can Control Z along the way till I put it back to its starting point.
But if you cut it, you have to end up reconnecting, closing the vector to calculate, right?
Let me rephrase what I think I heard. If I have an open vector, I cannot use it in a pocket toolpath or a V-carve toolpath. Okay?
You said
All I have is a line, and the only way I could use it would be in a profile cut.
Yeah.
Okay, that's where we are. Okay, so this is node editing mode. I can delete a span. Yeah, that's the term I couldn't come up with earlier. Where I did have a span connecting those two nodes, it's now gone. Control Z, back, put it back. Like I said, you can cut it. You can cut a vector. I'm cutting it in two locations here, and each place I cut it, here, I've got a green starting point. Now, if I select it, that little area, wait a minute, I did cut it. I did cut it. Okay? But now that I've taken a little section out of it, let's connect it back together again. I hope they touch properly because I've got it selected. I can go over and see if I can close it, and yes, I can close it. But now that I have closed it, and I select it, and I go into node editing mode, notice the starting point, the green, it designates the starting point of the vector. It used to be this corner up top. Now it's here as an intermediate point in this line.
But you still have the removed line.
Yeah, I can delete them. I mean, or I might want to use them someplace else. Now here we're talking about the power of manipulating existing objects and changing their shape, changing the starting point. And of course I can set up a tool path to always start on the green dot. So I can move that green dot around to achieve a higher performance of moving from vector to vector to vector during a cut.
From a finished cut standpoint, is there a preferred starting point, like a corner? It doesn't matter.
It's, well, preferred in standard, no. But preferred in higher performance, there could be a strategy where you look from vector to vector to vector and you see the stop point of a cut and you make the start point of the next cut close to there and minimize the time moving the tool around. We're getting into the art, and it's a first step towards creating custom designs. Yeah, we can always work with circles and squares and stars, and there's some other tool paths that I can't get to in this course, that you can overlay a circle with a square, join them together so that they're now an interesting design. But the basics all fall back to the capabilities of the node editing mode. Okay. Where you can break something apart, put it back together again in a different shape. Practical example, Wes left, so he's not here to keep me honest. He was doing a personal engraving onto a cutting board for Donna Lease, the activities director. And she had chosen a font for her family name, and she had added some closed vectors at the beginning of the script and at the end of the script. And when he did a when he did a cut, he was actually doing 3 or 5 cuts, and they just weren't flowing together in the final image that was being cut. So he and I sat together and we took node editing mode, and we took the slope coming in, individual letters, the slope going out, and we tied them together just by cutting the closed vectors and rerouting that particular line to a cut on the next vector along the way. So yeah, you can take font and manipulate the font that it's generated for you using these techniques. Okay. Node editing mode, remind me, and I will, well, I think I do have a video specific on node editing mode tonight. We'll see about that. Okay, let me get rid of all of the changes that I made. And now I can put the file away and I know its status. You asked for the dimensions of the machine earlier. There they are. The dimensions of the planer is here. These, the planer dimensions determine the size of the project we're working with. Oh, yeah, one last one here. Let's go back. And instead of the medium box, let's open okay, there's, this is the husband and wife project box that uses, I'm not going to save any of those changes. This is a large box about that size, and 2 pieces of material are needed to cut the box. Now, as we over the years that we've been building these boxes, this one happened to be the Vectric software. You had to have a separate file for each piece of blank material. This falls into that category. When he built this box, yes, 2 different pieces of material, 2 different files. And Vectric's found that it was cumbersome for us to transfer between files to get the dimensions right. So along came a new Vectric feature on the previous version. That was version 11. It's called Sheets. And what Sheets is a modification to the setup structure that we talked about early on. Instead of specifying the dimensions of the material in the setup box, in the setup area, this is what I'm referring to here, the setup. Okay. Now here we have a file that requires 2 pieces of material, 2 different sessions to cut. So in the basic setup, it just tells me there's various dimensions involved. And with that knowledge, I can go down to the sheets. And this is a tab along the left-hand set of tools. And the sheets allow me to set up dimensions for 2 different pieces of material. The box sides, which is pointing down here, I have the box size in a piece of material 19 inches wide by 7 inches high. And then the box front, back, and top are in a piece of material 14 inches wide by 18.5 inches high. Okay, so I can switch between the 2 as I'm drawing. I can switch between the 2 as I need to. Go ahead.
So, the ends in this drawing, the grain would actually be running in the alternate direction than what this box is constructed.
That could. It could. No, it turns out it's not. Both in this particular design, the grain pattern runs left to right. Left to right. Here on the front of Wes chose to build his box with the grain pattern running this way.
Right.
I choose to build all of my boxes with the grain pattern running left to right. Left to right here and left to right here.
Right.
It's just,
Okay, so, yeah, okay.
but the bottom line answer is that there's no implication of grain pattern in these sizes.
It's just how you make your blank.
Okay. Pardon?
It's how you produce your blank.
Exactly. Yeah.
It would have been easier to produce the ends running this way, assuming normal board.
Yeah. Yeah. The yes, I agree. So if I want to, for drawing purposes, if I want to switch between, I can just double click over here, and it's going to take a moment or two, but it will switch over to the piece of material, he said. Well, I said there were two ways. I can go up top here to the, and I can specify I want to focus on the box sides. There, finally. The software caught up with, the software caught up. So yeah, here of course I'm focused on this piece of material and I'm creating the vectors needed to cut the box sides. And if I switch back here, eventually it'll come back. There, it came back. Okay, those are sheets. There's no limit to the number of sheets that you can have. And they make sense if you want to have cuts on various pieces of material match up. This is a way of laying out your entire project in the software and then managing it through one file.
If you're doing an inlay,
Pardon?
if you're doing an inlay, would sheets be easier to use? To cut it on one?
Very, very great question. I'll be there in a moment. Okay, very great. Concept of sheets is really what I wanted to cover. We're going to talk about details of this design 2 weeks away and during night 6 of the class. Okay, so we've modifying the box structure is feasible if should you want to. I'm assuming that it's so easy to use the planer to create the medium box size that we'll all stay with that for this first box. But in the future, of course, you can make the dimensions whatever you need for your use. Decorations is where we have the ultimate flexibility. And I list here the 3 decorations that I've used in the project box files that you can download. I've used chip carving. This is the chip carving. And by the way, I have a video for you tonight on chip carving. Okay. I found that to be a very flexible tool to create whatever pattern I want. And I would recommend that you do experiment with it. The swirl pattern The swirl pattern we've looked at before, and you can pass that around. It's a student in our very first class. We experimented to get her a swirl pattern for her box, and she was very satisfied with it. And then, of course, the basket weave. The basket weave is the pattern that Alan mentioned earlier, and we have on the cut CNC blank here. That's just a series of rectangles that we created one little tiny rectangle, and then we propagated it throughout the screen to achieve that pattern. That's very... There are tools in the software that I want to cover briefly that, that make both the chip carving and the... pardon? I'm sorry?
You have a question here.
Okay. Somebody had a question?
I was going to ask you, looking at the basket weave, is there a way to replicate that rectangle in such a way that it fits in?
Another presumptive question. I'm headed that direction.
Oh, all right, thank you.
Back to the software just for a moment. Okay. Over here in design mode, there's a set of offset and layout tools. We've used the tool to the left in this box that can simply take a vector, a closed vector, and if I want to create another one that is 0.5 inches larger than that one, I can offset it, and I've created another vector larger than it was. Okay? Let me back out of that. Should I want to take this should I want to take that pattern and break it apart, let's ungroup it. So if I want more of these little boxes, I can go into a tool here that gives me a rectangular copy capability. Let's just say I'm moving 0.25 inches X and Y, and I'm starting point, I'm going to go 10 rows across, 10 columns high. Okay. Well, a battery did give out on me. There we go. So that shows how this particular border was originally created. Just repetitively copying those little triangles that create an interesting V-carve pattern. So let me
highlight the interior columns and rows and delete. Can you highlight the interior columns and just delete?
Yes.
Okay.
Yes. Sure. Now, here I've done it using the horizontal and vertical copying tools. There's also a tool next door, and running out of time tonight, I'm not going to be able to demonstrate it here, but here we have this creates a circular pattern. Now, if you look at the center of the chip carving, more, and going out from the center out, Or conversely, you could come out and go down into the center to create the pattern that you want. That is acceptable.